Hello everyone. Now in this segment, we'll be looking at how to solve this nuclear physics problem. Okay. Now this is a challenge question given to me. Okay, and now this question, okay, is a question about cyclotron. That's a particle accelerator. We have different types of uh, particle accelerator. Okay, there are two major classifications of particle accelerator. We have the linear accelerator, and we also have the cyclic accelerator. For the linear accelerator, we have the drift tube particle accelerator. That's drift tube accelerator is an example of, or is a type, or sorry, is a type of linear accelerator. Then when it comes to cyclic accelerator, just like what we have here, cyclotron, okay, where the particles are forced, to travel repeatedly through a modest electric field by the action of a transverse uniform magnetic field. And these particles acquire energy in small portions. Okay, when they acquire energy in small portions, that will ultimately accumulate to a very high amount. So that means the energy will be accumulated to what? To a very high amount. So the first cyclic accelerator, okay, was built by E.O. What's his name again? And I remember we have M.S. Livingstone. Okay, now that's in the year 1932, and then this other guy. Okay, yeah, I know there were two of them who actually built the first cyclic accelerator. So now, when it comes to cyclotron, like I said, okay, now in cyclotron, the charged particles, okay, moving in a transverse uniform magnetic field will describe a circular path. So because it describes a circular path, so the frequency of revolution, which is independent of the velocity of the particles, will now be given by the formula. Yes, we can prove this formula, and I can also, draw the diagram of what cyclotron looks like, but it is not necessary because maybe if I come across a question where I'll need to draw, the diagram and explain the working principle of a cyclotron. We have different diagrams, but one of the diagrams, the one I know about, which I'm very sure about, is the one we call the schematic diagram. So in this case, so we have, like I said, the frequency of revolution, F, is the frequency of revolutions. We can also use V, we can also use V. We can also use this V, this V letter, to represent frequency of revolution. Now, Q is the charge. This will be the charge on what particle are we given in this question? Okay, deuteron. So the charge on deuterons, okay? Yeah. Then we're also giving the magnetic flux density. Okay, we have the magnetic flux density. Now we also need the mass of the charged particles. So that's mass of deuterons. Okay, mass of deuterons. So now let's write down now the formula. Okay, the formula for the frequency will be QB, okay, over 2 pi m. So where m, like I said, the charge on deuteron, Q would be the same as the charge on proton. Proton is a positively charged particle. So, and the magnitude of the charge on proton is 1.602 times 10 raised to the power of what? Negative 19 coulombs. Then also mass of deuteron. Okay, the mass of deuterons is 3.34, yeah, times 10 raised to the power of negative 27 kilograms. Like I said, like I explained in one of my videos, that when questions, most times I always come across questions, or I've solved, questions, a lot of questions when we are not giving some values, because it is assumed that we already know these values. So just like what I'm doing now, okay, now there's a way we can actually calculate the mass of deuterons. Now we know that the atomic mass is 3 points, so we are multiplying. So, but what is important here is to know all these values. So the charge on deuteron is 1.602 times 10 raised to the power of negative 19 coulombs. And the mass of deuteron, this is the mass of deuteron. Okay, so what again are we not? Okay, we're also giving the magnetic flux density, which is 3 Weber per square meters. I think that's okay. So we want to calculate the frequency. Now to calculate the frequency, we have frequency to be QB all over 2 pi n. This is the frequency of revolution. Okay, when we have a charged particle in a transverse uniform magnetic field, okay, describing a circular path, okay, describing a circular path. So that's in the case of cyclotron. So we have F to be equals to 1.602 times 10 raised to the power of negative 19 multiplied by 3 all over 2, then pi, that will be 3.142 multiplied by the mass of deuteron, which is 3.34 times 10 raised to the power of negative 27. Okay, so now let's get the value for what is 1.602 times 3. That's 4 points. So the frequency is 4.806 times 10 raised to the power of negative 19. Divide by, so what is 2 times 3.142 multiplied by 3.34? That will be 20. That is 20.989. Then multiply by negative 27. Okay, so now let's divide 4.806 divide by 20.989. Okay, that would be, so we have the frequency to be 0.22, okay, 0.229 multiplied by 10 raised to the negative 19, then plus 27. The unit of frequency is the hertz. So this would be 2.29, okay, times 10 raised to the negative 1 multiplied by negative 19 plus 27. That will be 8. Yeah, that will be 8. So F will be equals to 2.29 times 10 raised to the power of 7 hertz. So this is the frequency of revolution, okay, for a charged particle moving in a transverse uniform magnetic field, okay, which describe a circular path, okay. That's in the case of what? Cyclotron Ds. Like I said, in a cyclotron, in a cyclic accelerator, because we have two types of accelerators. We have the linear accelerator, just like the one I mentioned, that's the drift tube accelerator, is a linear accelerator. We have Betatron, you know, we have the cyclic accelerator like Betatron, Cyclotron, Synchrotron, and all of that. So in the case of cyclotron, okay, the charged particles are forced to travel repeatedly through a modest electric field by the action of what we call a transverse uniform magnetic field, okay, and these particles will acquire energy in smaller portion, okay, which will ultimately what? Accumulate to a very high amount. That's in the case of cyclotron. You know, when I talked about Betatron in one of my videos, I said Betatron produces fast moving electrons, okay, because they can produce energy up to about 300 mega electron volts. Yeah, that's in the case of Betatron, because this accelerator, the name of the accelerator is called Betatron, and it produces fast moving electron. And we know that fast moving negatively charged particles, they are called beta particles. The noblest pleasure is the joy of understanding. Bye bye.